This is my intermediate algebra course. Today we're going to continue to learn how to graph quadratic expressions. If you haven't done the homework completely and correctly from last class, do that homework before watching this video. In the previous class, we learned the exact definition of a parabola and how to plot the focus and draw the directrix. And in the classes before that, we learned how to find the x and y-intercepts of a parabola and the vertex and also the line of symmetry. Today we're going to finish our study of quadratic expressions and, well, not really the quadratic expressions, but we're going to finish our study of parabolas, the graphs of quadratic expressions, by reviewing everything that we learned. And I know what you're thinking. You're thinking, we've done this enough. We don't need to do it anymore. But we do need to do it more because, like I mentioned previously, quadratic expressions and their graphs, parabolas, are one of the most important parts of this curriculum. So you need to know this stuff like the back of your hand for multiple reasons. So every class that I do on graphing quadratic expressions is completely necessary, so please be aware of that. So this information here is all review. You've seen all of this, but you can take a screenshot if you don't want to go back and look for this information. But this information here is kind of it's a review of everything that we learned when it comes to graphing quadratic expressions. So I want you to go ahead and take a screenshot of this information. We're going to use this today. And as you can see, it's a summary for graphing quadratic expressions. And in green, you see here, it's titled The Steps for Graphing a Parabola That Opens Up or Down. Now, we have not learned how to graph parabolas that open to the left or to the right. Just be aware of that. We're going to learn that probably in pre-calculus. But we're just going to focus on up or down parabolas. And as you can see, I have the steps for graphing those types of parabolas. Step 1, identify the form of the quadratic expression and use it to find the vertex of the parabola, the most important point. Then draw the line of symmetry and write its equation. Then find the y-intercept, then find the x-intercepts, and so on and so forth. So this is just a guide for you if you forget exactly what to do. At this point, you really should know what to do. You really shouldn't have to have a guide, but this is something that will help you if you're kind of lost in terms of what to do first. You don't have to follow the order there. So get a screenshot of all that. You don't have to follow the order of these steps, but we're going to go ahead and follow that order today, just so you can get used to using those steps. So it says here, graph the following quadratic expressions, and as you see, we're going to do everything that we learned in previous classes. We're going to plot the vertex, the y-intercept, the x-intercepts, and the focus, and we're also going to draw the line of symmetry and the directrix and write their equations. That's pretty much everything that you need to know when it comes to graphing quadratic expressions. And that's going to take a while for each problem to do that. So notice that there are only 8 problems. So don't worry, I'm not going to give you a ton of these problems. We only have 8 to do today. So that said, let's get started. Now notice that this is, well, first of all, let's go to step 1 here. It says step 1 is identify the form of the quadratic expression and use it to plot the vertex of the parabola. So what form is this? Obviously this is standard form. So I'm going to go ahead and label constants. You don't have to label constants, but I'm going to do that just to avoid any confusion. And so we have standard form, and we're going to use that form to find the vertex. And so step 1, we're going to find the vertex. So I'm going to label that step vertex. And if it were in standard form, you know to use this formula. That's just something that we've done again and again and again. And so B is 2 and A is 1. And that simplifies to -1. And so now we're going to find the y value of the vertex. And as usual, you know to find the y value of the vertex, you just plug in the x value into the original expression. And simplify. So the y value of the vertex is going to be And you know what? I'm not really going to show all those steps because we don't really have time for that. That's going to be 1 minus 2 is negative 9. So the vertex is negative 1, negative 9. So that is step 1. Now, if we want to use this particular order, the next step it says here is to draw the line of symmetry. And so the line of symmetry, when you're dealing with parabolas going up and down, that's pretty easy. And I'm going to label this step line of symmetry. Line of symmetry is just going to be x is equal to negative 1. And by the way, we should probably plot these. So negative 1, 9. Or excuse me, negative 1, negative 9. So it's going to be 1, 1, 2, 3. Whoops. Sorry about that. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that point right there. And the line of symmetry is going to go right through that. It's always vertical. So again, this is all review. We're just doing everything for each graph now. So that was pretty easy. Now step 3. What does it say on step 3 over here? It says let x equal 0 and find the y-intercept. So we're going to let x equal 0 in the original expression. But first let's title this step y-intercept because we're finding the y-intercept. And to do that, we let x equal 0. And when you're in standard form, it's so easy to find the y-intercept because if you let x equal 0, these all go to 0 and you're left with negative 8. So the y-intercept is just going to be 0, negative 8. We don't have to show the math on that. It's just not necessary. So now we're going to step 4. Step 4 is we're going to let y equal 0 to find the x-intercepts. Now this step can be a little involved, so you need to be prepared to do some math on this step. Turns out this problem is going to be factorable. So we're going to let y equal 0. And so we're going to take that original equation and rewrite it, but we're going to let y equal 0. X squared plus 2x minus 8. And so now we have to solve that equation, but that's a special equation. That's a quadratic equation. And so we can't solve it with the normal methods. Now, over here it says if the expression is in standard form, which it is, then there are 3 ways to find the x-intercepts. You can factor, you can complete the square, or you can use the quadratic formula. Now, you never want to complete the square. You never want to use the second method here, unless somebody forces you to, unless your teacher says you have to. Because completing the square is the most difficult method. It's the longest method, the most tedious method. You always want to see if you can factor first, and if you can't factor, if you're not sure if you can factor, then you use the quadratic formula. So we're going to talk about the quadratic formula later, but it turns out that this expression is factorable. It's a quadratic, so remember when you factor a quadratic, you factor to a product of binomials. And if it were not factorable, then you would use, when I say quadratic formula, I'm referring to this formula that we learned in a previous class. But we're not going to do that in this problem because the expression is factorable. So what 2 numbers multiply to negative 8 and add up to 2? Well, that's going to be 4 and negative 2. Now, be aware that if there's a coefficient here, it's not that easy. You ask how many, or what 2 numbers multiply to negative 8, but they're not necessarily going to add up to 2, so you'd have to use trial and error, so just be aware of that. Okay, so we changed the form of this expression, and why did we do that? Well, the reason we did it is because now we can see what the x-intercepts are. We can see numbers that we can plug in there to make the expression 0. Those would be the x-intercepts. So I'm going to go up here and we see that one answer is going to be -4, and the other answer is going to be +2. -4 and +2. So that means that the x-intercepts are going to be -4, 0, and 2, 0. So we can go ahead and plot those. All right. And we didn't plot the y-intercept, by the way, so I'm going to go ahead and do that now. 0, -8. That's going to be all the way down here. All right, so we're moving right along here. We're on to step 5. So step 5 says find P, which is 1/4a, and use it to draw the directrix. I'm reading here. Okay, so the directrix is the next step. It's going to be step 5. And I'm going to title that directrix. And by the way, this should be x-intercepts plural. And so for the directrix, the equation, first of all, we have to find P. So P is equal to 1/4a, and we know what a is. A is just a is just the coefficient of x squared. That's just 1 in this case. So you plug in 1. And you know what? I'm not going to do a slash on that. I'm going to do it vertically. 1/4a, 1/4 times 1. And that ends up being 1/4. So we have P now. So now we can easily find the directrix. Remember, the equation for the directrix is it's a horizontal line, so it's going to be y equals the y value of the vertex minus P. And the y value of the vertex over there we see is -9. So that comes from there. And then we're going to subtract P, which is 1/4, and I got that from there. So if you put those together, we can just go ahead and write that in mixed number form. So it's going to be -9 and 1/4. Okay, so now we just need to find the focus. And before we do that, I'm going to go ahead and graph the directrix. So -9 and 1/4. That's going to be down here. I can go ahead and graph that. Y equals -9 and 1/4. I'll worry about the other points later. And the focus, to find the focus, we just plug in the x value of the vertex, and then the y value of the focus is the y value of the vertex plus P. So the x value of the vertex is -1, and the y value of the vertex is -9, and then we're going to add 1/4. And let me make some more room here. And also, we don't need to rectangle that line of symmetry, or the equation of the line of symmetry. So now the focus is going to be -1 and -8 and 3/4. Let's graph the focus, -1 and 8 and 3/4. That's going to be about here. So let's go ahead and draw the graph. And remember, this is not an art class, so your parabola doesn't have to be perfect. But it does have to look somewhat like a parabola. And try not to make it too pointed near the vertex. I have a habit of doing that. Okay, and let's see if we can label some of these points. Try to make enough room. Those are x-intercepts, and the line of symmetry is x equals -1. And the y-intercept is 0, -8. And the vertex, which we're going to label V, is -1, -9. And I think we just need to plot the focus next, so that's going to be -1 and -8 and 3/4. And that's it. So as you can see, when you're forced to plot the x and y intercepts in both lines of the line of symmetry and the directrix and the focus and the vertex, it's quite a bit of work. And sometimes you're going to be asked to do that. But again, don't complain, because we're only going to be doing 8 problems today. That's it. And reviewing this stuff is just something that we have to do. We've got no choice. This is the most important part, really, of the entire curriculum. Okay, so let's do another one of these problems. Now we're in intercept form, and the first step here is, like I did before, is to identify the form. So we know it's an intercept form, and so we can go ahead and label the constants. And remember, it's opposite sign, so this is +3, so it's going to be -3. Not that it really matters in this particular problem. And step 1, we're going to find the vertex, so I'm going to label that vertex. And remember, to find the x value of the vertex, we use that old familiar formula when we're in intercept form. So we have -3 + 3 over 2, which of course would just equal 0. And to find the y value of the vertex, we're just going to plug in the x value of the vertex into the original expression. And the x value of the vertex was 0. So I'm just plugging in 0. And finally we get, that's going to be +9/2, or we can just write 4.5. Okay, so the vertex is 0, 4.5. Step number 2, we're going to find the line of symmetry. And that's really easy. It's just going to be x is equal to whatever the x value of the vertex is. So, that just comes from here. Okay, and step 3, I think I might hold off on graphing this stuff until I do all the math. Step 3 is to find the y-intercept, and of course when you do that, you let x equal 0. And we're going to plug in 0, but we don't really need to do that, because when x is 0, we already know that it's just going to be the actual vertex. The y is going to be 4.5. So the y-intercept is just going to be the same as the vertex. So that step actually wasn't really that helpful. Now we're going to find the x-intercepts. So I'm going to label this step x-intercepts. And to find the x-intercepts, as usual, you would let y equal 0. Now, it's very important to understand that because this is in intercept form, we can actually see the intercepts just by looking at it. It's -3 and +3. Remember, it's just the opposite signs. So we don't really have to do any math for the x-intercepts. So -3 is 0, and +3 is 0. So we're done with that step. Step 5. What is step 5? Let's find P, because we're going to find the directrix. We're going to draw the directrix, and we need to find P. So P is equal to 1 over 4a. And of course a, we have up here, a is -1/2. So I'm going to plug in -1/2. And maybe I should color code that. Probably should have done that up here. There you go. I know you don't really need me to color this at this point, but it's just one more thing to help you figure things out. Okay, and we don't really have time to show the math on that, but that's just going to be -1/2 if you simplify all that stuff. So we know P is -1/2, and the equation of the directrix is y is equal to the y value of the vertex minus p. So the y value of the vertex, I'm going to color, what did we color that last time? We colored it blue. And well, I guess we can't color blue this time, but whatever. So that I'm going to make it green. And P will make some purplish color here. P is -1/2. So the y value of the vertex is 4.5, and P is, sorry, sometimes it does that, it just flies over there for no reason. P is -1/2. So if we simplify this, we get y is equal to 5. So that's the equation of the directrix. Okay, so now we're going to step 6. And that's going to be to find the focus. And to find the focus, the x value of the focus is the x value of the vertex, and the y value of the focus is the y value of the vertex plus p. So the x value of the vertex is 0, the y value of the vertex is 4.5, as we said, and p is going to be -1/2. Remember, we found p is -1/2. So the focus is 0, 4, if you do the math on that. And that's it. That's all the work that we pretty much have to do. Now we just have to graph it. So the vertex is 0, 4.5, which is about here. And the line of symmetry is x equals 0, so that's going to be right on the y-axis. So that is the line of symmetry. And then the y-intercept is going to be 4.5, but that's, you know, that's the same as the vertex. And then the x-intercepts are there, 3 and -3. And the directrix is y equals 5, so that's going to be up here. Remember, the directrix is always a horizontal line. And I can go ahead and write that equation, y equals 5. And what else do we have? We have the focus is 0, 4. So that would be here. And now we can draw the parabola. And if we plot more points, we can have a more accurate parabola. But that would require more work, and as you can see, we already have quite a bit of work that we have to do here, so I'm not going to make you do that. That was not a symmetric parabola. I got to draw that a little better. There we go. Okay, so this is -3, 0, and 3, 0, and the vertex is 0, 4.5, and the focus is 0, 4. And we just need to write the equation of the line of symmetry, and that's it. So again, that's another example where we're pulling out all the stops here. We have to do every single thing. This is called analytical geometry, where we have to plot all the significant points and lines and so on and so forth. Okay, so on to another problem here. We're going to do a couple more of these before you try one on your own. I know what you're thinking. You're thinking, okay, I got it. I want to try one of these on my own. But, you know, we're going to do a couple more. You're going to do 4 of these problems, the last 4. But I want you to get the hang of how to follow these steps here. Again, you probably don't need these steps at this point, but I just want to give you a guide. So first step is to identify the form of the quadratic expression. That's over here. And in problem number 3, you can see that this is in vertex form. So we're going to label constants. A is -1/4, and H is -3, and K is +3. Remember, the sign changes here, but it does not change here. And step 1 is to find the most important point of a parabola, which is the vertex. And the x value of the vertex is just going to be h, which we just found is -3. And the y value of the vertex is going to be k, which we just found is 3. So the vertex is -3, 3. Now we're going to find the line of symmetry. Which is x equals whatever the x value of the vertex is. So there you go. That was easy. That's one of the easiest things to do here. Now we're going to find the y-intercept. And to do that, of course, we let x equal 0. So we're going to copy down that expression up there, but except we're going to let x equal 0. And we're going to solve for y. Just make sure I got all that right. So 0 plus 3 is 3, and then 3 squared is 9, and 9 times -1/4 is -9/4. So we get -9/4 plus 3 is equal to y. And this is going to be -2 1/4. And if you add that to 3, you get 3/4. So all that's going to be 3/4. Now, I don't know if I should show the work on this or not. We don't really have time or the room to do that, so I'm just going to pass on showing the work. If you want to see that work, you can go to previous classes. But again, that's just order of operations. You can review order of operations in my arithmetic course. So y is equal to 3/4. So what that means is that the y-intercept is 0, 3/4. Okay, so now we're going to find the x-intercepts. And to do that, of course, we're going to let y equal 0. When you find the x-intercepts, you let x, or when you find the y-intercept, you let x equal 0. When you find the x-intercepts, you let y equal 0. So I'm going to copy down that equation again. And we're going to let y equal 0. You see, to find the y-intercept, we let x equal 0. To find the x-intercept, we let y equal 0. Very, very important to understand that. Okay, so now we're going to solve. And, you know, in the previous problems, well, in the problem that we did previously, we actually, the y-intercept, or the x-intercept, you know, we could just see it by looking at the equation. But in this problem, what's the situation here? If it's in vertex form, then you have to solve an equation with the square. So in the previous problem, we had an intercept form, so we could just see the x-intercepts just by looking at it. In the first problem we did, we had to use factoring. One of those three methods, factoring, completing the square, or the quadratic, and factoring worked. But in this situation, we have vertex form, so we can just solve an equation with the square. So I didn't want you to be aware that's how to use those steps there. That tells you what to do. So when I say solve an equation with the square, sorry, this thing is bouncing around. When I say solve an equation with the square, this is what I mean. You're solving this equation. We did this in previous classes in this course, and we had an entire class on this in my beginning algebra course. So we need to get this square by itself. It's not by itself because the -4 and the 3 are next to it. So first we're going to subtract 3 from both sides of the equation. And I'm definitely going to show the steps on this just to make sure you understand. And, you know, there's a lot of ways to do this. Okay, You know, what you could do, what I did in my beginning algebra course is I just changed this to x plus 3 squared over 4 negative equals negative 3. And then the 3 you can change to 3 over 1. And then you can multiply both sides of this fraction here by 4. And then you get negative 12 over 4 is equal to all that stuff. And these, this equation tells us that these fractions are equal. The blue fraction is equal to the green fraction. That's what it's telling us. But notice that the denominators are the same. So if the denominators are the same, that means that the numerators must be the same. That's how we did it in my beginning algebra course. There are faster ways to do it, but I find that students prefer the way that I just did it there when it comes to their understanding. So that just means that we can get rid of the denominators, and now we have negative x plus 3 squared is equal to negative 12. And, you know, if we want to skip a step there, we could take that negative away by putting it in the denominator, but I'm not going to do that. I don't want to confuse you. So now we can just multiply both sides by negative 1. I'm not going to show that step or explain it because, you know, that's really just a pretty easy step. And now we've isolated the square. The square is now by itself. So what do we do now? Well, we have to get to the x, but we can't get there unless we get rid of this second power because the x is kind of trapped inside there. So the opposite of squaring is square rooting. So to get rid of the square, we're going to square root. And remember, whenever you do that, you have to write plus or minus. And that gets rid of the square. And if we get rid of the square, the second power, that is, when I say square, I'm referring to this. And by the way, I know a lot of you already know this stuff, but I'm just reviewing it anyway. So when you get rid of the square, you don't need the parentheses in there anymore. So now we have plus or minus square root 12. Now, remember, we did a lot of stuff involving roots, so I'm just going to simplify this without explaining it. But if you want to know how I changed this to this, you can go back to the classes on roots. Okay, so now we just have to subtract 3 from both sides, and you can write the negative 3 in front of the 2 root 3 or on the other side. It really doesn't matter. Okay, so that is those are the two solutions, and that's going to show us what the x-intercepts are. But the problem is we don't know what that number is. You know, I mean, what is this number? We don't know how to graph that. We don't know where it is on the graph. So we're going to have to get the calculator out to estimate what these numbers would be. So let's get the calculator. And I'm going to, there's a lot of different ways you could do this, but I'm going to write 3, and I'm going to push the square root button, and I'm going to times that by 2, and then write equals, or push equals. I'm going to add 3, and then change it to a negative, and then equals. So 0.464. So one answer is 0.464. And the other answer is going to be the same thing, except we're going to put a minus in front of the root. So we have 3, let me move this over a little bit, 3 square root button, and then times 2 equals. Now I have to change that to a negative because that's one of the answers, and then plus 3, change that to a negative, and equals negative 6.464. Negative 6.464. Yeah, I know we're kind of scrunched in there. Now I'm going to order this a little differently here. First I want to explain that x can be negative 3 minus 2 root 3, or it can be negative 3 plus 2 root 3. I should probably mention that. And so I don't remember exactly how I did this or how I showed it in the previous classes, but these are the two x-intercepts. The actual numbers that we're going to plot, of course, are these expressions. We're going to plot the actual exact expressions. But we wrote this to show us where on the graph we're actually going to be plotting. So that was kind of a hard step on this particular problem to find the x-intercepts, because as you can see, these x-intercepts are what we call irrational. Remember that term irrational? When you have a root there. Okay, so on to step number 5. We're going to find the directrix, and that's y is equal to the y value of the vertex minus p. Plug in the y value of the vertex, which is going to be 3, and then subtract p, and we have not found p yet. I forgot to do that. So p is equal to 1 over 4a, and a is equal to negative 1/4. So I'm going to color that green, and if you simplify that, you get negative 1. So we have 3 minus negative 1, so that becomes a positive, so 3 plus 1 is 4. So the equation of the directrix is y is equal to 4. All right, step number 6. I think I'm going to have to make more room here. We're going to find the focus. So the x value of the focus is the x value of the vertex, and the y value of the focus is the y value of the vertex plus p. Sorry, I forgot to show that. So x value of the vertex is negative 3, y value of the vertex is positive 3, and then we're going to add p, and p up there is, as you can see, it's negative 1. So I got that p value from here, and that's the y value of the vertex, and so on and so forth. I don't know if I have time to color code all these. Maybe I'll come back and do that, but it's just kind of a lot to do when you're trying to actually calculate this stuff. So 3 plus negative 1 is 2, so that's the the coordinates of the focus. So now we just have to graph. The vertex is negative 3, 3. And the line of symmetry obviously just goes straight through that as usual. And the y-intercept is 0, 3/4. So that's going to be about there. And the x-intercepts, that's where we have to use this information, the decimals here. There goes my screen again. It just disappeared. I don't know why it does that. Sorry. These numbers here. We have negative 6.4. So negative 6.4, 1, 2, 3, 4, 5, 6. That'll be about here. And we have 0.46, which will be about here. So those are the x-intercepts, and the directrix is going to be y equals 4. 1, 2, 3, 4, so that's up here. Remember, the directrix is always a horizontal line. I'm going to go ahead and write the equation of the directrix, y equals 4. And the focus is negative 3, 2. 1, 2, 3, 1, 2, so that's going to be here. Okay, so now we can go ahead and draw the parabola. And again, it could be more accurate if we had more points, but that would require more work. Okay, and now we're going to, let's see, we can write the equation of the line of symmetry, which is x equals -3. And we'll plot the vertex, which is -3, 3. And we'll plot the focus, which is -3, 2. And the y-intercept is 0, 3/4. And now the hard part is going to be the x-intercepts. We're going to have to try to fit those expressions. When we write the x-intercepts, we're not going to write these rounded off numbers. We're going to write the exact numbers. So over here we have -3 minus 2 √3, 0. As you can see, it's kind of hard to fit in there. And then over here we have -3 plus 2 √3, 0. And I guess I'm going to have to write that somewhere else. It is kind of a challenge to figure out how to fit all this stuff on the page. But just try your best. 0, and looks like that's going to be it for this graph. We have all that information written there. Okay, so let's try one more of these. Just one more before you try one on your own. I know you're probably thinking, okay, I got it, I want to try one of these on my own, but just one more, and then you're going to have the last 4 problems for yourself. So first step, identify the form of the quadratic expression. So what form are we in for problem number 4? Well, that's standard form. So we're going to go ahead and label constants in standard form. And first step is to find, of course, the vertex. So I'm going to label that step vertex. And when you're in standard form, the x value of the vertex is -b over 2a. That's just the way it always is. And b is equal to 6, and a is equal to -2. So if we simplify this, we get positive 3/2. And so to find the y value of the vertex, of course, we're going to take the x value and plug it in to the original expression. So we have -2 3/2 squared plus 6 times 3/2 plus 3. Now, if you're thinking to yourself, that's going to be a lot of work. You're right. It is going to be a lot of work. Sometimes you have to deal with a lot of tedious mathematics. It's just something that you're going to have to deal with. So 3/2 squared, that's just going to be 9/4. And then 6 times 3/2, that's just going to be 9. I'm skipping some of the steps here because, again, we don't have time to show everything. And -2 times 9/4 is going to be -9/2. And 9 plus 3 is going to be 12. Again, this is just basic arithmetic. So if you're complaining that I'm going too fast with this stuff, this is really, teachers at the intermediate algebra level, they usually don't show how to do this arithmetic. They assume that you know how to do it. So that's just the way it is. And we don't really, there are certain points in this class or in this course where we just don't have the time to show the arithmetic. You can go back and review my arithmetic course if you want to go back over that. So now we have -9/2 plus 12, and I'm just going to actually go out to the side here. So this is -4.5. So it looks like this is going to be 7.5. So the vertex is 3/2, and you know what? For graphing purposes, I'm going to go ahead and change that to 1 1/2. 1 1/2 and 7 1/2. That's the vertex, and just to be absolutely clear, that's the same as 3/2. Okay, so we found the vertex, and now we're going to find the line of symmetry. Or the equation of the line of symmetry, which is x is equal to 1 1/2. That was an easy step. Now we're going to find the y-intercept. And to do that, we're going to let x equal 0. And that's really easy when you're in standard form because the y-intercept is always equal to 3. That's one of the principles that we talked about. That's one of the principles at the beginning of the class that we have written down. So that's the y-intercept, and now we're going to find the x-intercepts. To do that, we let y equal 0. Now, we're going to write that equation down, that original equation. Negative 2x squared plus 6x plus 3. And this is a quadratic equation. We have to solve that quadratic equation. Now, just to review here, when you're finding the x-intercepts, it says here, if the expression is in intercept form, you don't have to do anything. You can just see the x-intercepts. If the expression is in vertex form, then you have to solve the equation. You have to solve an equation with a square. That's what we did in the previous problem, I believe. But if it's in standard form, then you have to consider 3 options. Factoring, completing the square, or using the quadratic formula. Now, like I said previously, we never complete the square unless we have to, because that's the longest and most tedious method. So let's try factoring. And if that doesn't work, we'll use the quadratic formula. So if you try to factor this, it's not going to work. There is no number that when you multiply 2 numbers that you get 3, and when you do all the math and FOIL it out, you're going to get 6. First of all, you'd probably want to get rid of this negative. So you could multiply both sides by negative 1, and you get 2x squared minus 6x minus 3. And then you would try to factor what 2 numbers multiply to 2. That's 1 and 2. So 1 here and 2 here. And then you ask what 2 numbers multiply to negative 3, and you'd try maybe 1 and negative 3. And then you'd FOIL this back out to see if it equals that. But if you keep doing that, and again, we don't want to deal with negatives on the x squared coefficient, so we can just multiply everything by negative 1. If you multiply this side by negative 1, it just changes all the signs. And if you multiply this side by negative 1, well, negative 1 times 0 is just 0, so it doesn't really change it. But if you try to do that, you're going to find that you cannot easily factor this expression. It just doesn't work. So what that means is we have to use the quadratic formula. That big, nasty-looking formula. And a lot of students, they really hate this formula because it looks so complicated, but this is really basic math compared to what you're going to be doing when you enter calculus, so this is really not that big of a deal. Okay, so now we're just going to plug in numbers. So b is going to be 6. So plug in 6 wherever we see a b. And then a is going to be negative 2, so plug in negative 2 wherever you see a. And then c is going to be 3. And all we have to do is just simplify this big old purple formula, or the purple expression here, and then we have our x-intercepts. But we're out of room, so of course we're going to go up. Actually, I don't really need the arrow, I guess. So x is equal to negative 6 plus or minus, and now this part here, 3 times negative 2. Well, first of all, let me see if I have all this right. Negative 4ac 6 squared 2 times. Okay, that's correct. I don't want to do all that math if it turns out to be wrong. So don't be afraid to check your numbers. So 3 times negative 2 is negative 6, and negative 6 times negative 4 is positive 24. So we have 6 squared plus 24 in the root over 2 times negative 2, which is negative 4. And so continuing on here, and by the way, you don't have to show steps on this. You can do this, all in your head if you really want to. So now we have 36 plus 24 over negative 4. I'm just showing these steps for your benefit so you can review this stuff if you forgot how to do this from the previous classes, because this is all review, by the way. Okay, so 36 plus 24, that's 46, 56. It looks like that's going to be 60. And over negative 4. So now we cannot have a perfect square factor inside a square root. So we're going to factor 60 to 4 times 15, and the 4 is going to come out as a 2, and the 15 is going to stay inside. Now again, if you forgot how to do that, just go back to my class on roots in this course. Now if all that were not enough, we can now reduce, because these terms all have a factor of 2, so we can divide. That's the equivalent of reducing a fraction. So we're going to divide each of those terms by 2. And when you divide the 2 root 15, the 2 just disappears. And let's see here. So now, remember, when you have a negative here and here, you can kind of just get rid of those negatives. So we're going to simplify a little bit more, because when the plus or minus, that just stays plus or minus. We talked about that in a previous class. So that's the equivalent of dividing both sides by negative 1. You divide this side by negative 1 and divide this side by negative 1, or you can multiply both sides by negative 1. It changes this to a positive 2, and it uses the distribution rule, changes this to a positive 3, and when you multiply this by a negative 1, well, plus or minus just stays plus or minus. You can think about the logic of that later. Okay, so now we have two solutions. X can be 3 plus root 15 over 2, or X can be, instead of a comma I should write or X can be 3 minus root 15 over 2. And so that doesn't really help us because those numbers are kind of enigmatic. So we're going to use the calculator to find those numbers. And maybe I'm just going to write the coordinates first. Maybe that would be a little easier to understand compared to how we did it last time. So 3 minus root 15 over 2, 0. So those are the coordinates that we're going to graph. The problem is we don't know where to graph on the coordinate system, because we don't know what these numbers are. It's too hard to see what exactly they are. So we're going to have to use a calculator. So let's get out the calculator. And I'm going to write 15 and then the square root button, and then plus 3 equals, and then divided by 2 equals 3.43. So 3.430. So that gives us an idea of where that number is going to be on the actual x-axis. Then we're going to write 15 and then square root button, and then change it to a negative by pushing the plus minus sign, and then add that to 3 and then equals, and then divided by 2 equals, and we get negative 0.43. So negative 0.43. And so as you can see, that was a lot of work to find the x-intercepts. It was a lot of work, but there's no avoiding it. Sometimes you have to do all that math just to find those x-intercepts. Now the directrix is going to be y is equal to the y value of the vertex minus p, and the y value of the vertex is 7 1/2. And then we're going to subtract p, but we don't know what p is. We haven't found that yet. So I have to do that first. So p is going to be equal to 1 over 4a, and then we're going to plug in a. What is a? Up here it says a is negative 2. Whoops, computer's going kind of slow there. So we're going to plug in negative 2 here. and then we get negative 1/8. So now that we have P, we can use that to find the directrix. So I'm going to I have a little bit of room up here because I'm obviously out of room down there. And I'm going to color the y value of the vertex purple, and I'm plugging that in here. And I'm going to make this p value blue, I guess. Sorry, I'm not making these the exact same color each time, but it's just too much to think about when you're doing all this work. So the y value of the vertex minus p, and p is negative 1/8. Okay, so the equation of the directrix is 7 1/2 plus 1/8. And we're going to have to do some basic math on that. So 1/2 we can change to 4/8. And 4/8 plus 1/8 is 5/8. So that's going to be 7 5/8. If you need review on that, then you can go back to my arithmetic course where it talks about how to add mixed numbers. Or at the end of the course, we might go over adding fractions to mixed numbers. Okay, so now last step is to find the focus. I guess I'll just go up here. And so the x value of the focus is the x value of the vertex, and the y value of the focus is the y value of the vertex plus p. And so the x value of the vertex, that's in green, 1 1/2, and the y value of the vertex is 7 1/2, and then we're going to add negative 1/8. So we end up with 1 1/2, and remember this is the same thing as 4/8, so 4/8 minus 1/8 is 3/8. So we end up with 7 3/8. Okay, so now we can start to plot stuff. So let's plot the vertex. That's 1 1/2 and 7 1/2. So 1 1/2 and 7 1/2. 1, 2, 3, 4, 5, 6, 7, and 1/2. So that's about there. What else do we have here? Line of symmetry. As usual, that's a vertical line going right through the vertex. And y-intercept 0, 3. That's here. And x-intercepts. Now, for the x-intercepts, we're going to have to use these points in green here because it's too hard to use the irrational expressions. So we have 3.43 and 0. So that's going to be 1, 2, 3. That's going to be about here. And we also have a negative 0.43. So that's going to be about here. All right, so now we go to the directrix, which is 7 5/8. So that's going to be, it's kind of hard to tell exactly where that would be. It's going to be pretty close to the vertex, so you can kind of just plot it real close there. And then the focus is going to be 1/2, 1 1/2, and 3/8, so it's going to be somewhere around here. It doesn't really, the coordinates don't really have to be perfect because obviously this is kind of hard to graph. Okay, so let's now graph the parabola. And again, it's not going to be perfect. I should have gone through that point, but it's not perfect because we're not plotting every single point. Alright, so let's label the vertex. Actually, let's label some easy points first. So 0, 3, that's an easy point. And y is equal to 7 5/8. That's the equation of the directrix. And the equation of the line of symmetry is x is equal to 1 1/2. And let's see, what else do we have? The focus, we should probably go ahead and label the focus. That's 1 1/2 and 7 3/8. And then the actual vertex, that's going to be 1 1/2 and 7 1/2. Again, I know this is a lot to have to write down, but we're not going to be doing a lot of these problems. We've already done, this is the fourth one, we're only going to be doing 8 today. So 3 plus root 15 over 2, 0. That's one of the that's one of the intercepts, and actually that should be 3 minus 15 because it's on the left side. And then on the other side we have, let's see if we can fit this in, 3 plus root 15 over 2, 0. It's kind of a challenge to fit all that stuff in. And that's it. That's all the information there that we need. And I'll go back and highlight some of that if I have time. Okay, so now it's time for you to try. So I want you to try number 5, but be aware that number 5 is not going to have any x-intercepts. Okay, so this is going to be the first problem where there are no x-intercepts. Also, you can take a screenshot of all the problems that we did so far if you want to use these as a reference. And if you didn't get a chance, you want to take a screenshot of all this information here, and especially this information, which is going to kind of give you a guide if you forgot, or if along the process you forget, where you are, what to do. So go ahead and try number 5, and remember there's no x-intercepts, and when you come back we'll do it together. Alright, we're back. So the first step is to identify the form. This is vertex form, so we're going to write the constants. A equals 2, and h equals 1, and k equals 2. And the first step is to find the vertex, the most important point, and the x value of the vertex is equal to h, which is equal to 1, and the y value of the vertex is equal to k, which is equal to 2, which means that the vertex is equal to 1, 2. The line of symmetry is the next step, and you don't have to do it in this particular order, but I'm just going to stick with this order because that's the steps that I gave you on the summary. So x is equal to 1, that's just the value of the x value of the vertex. And now we're going to find the y-intercept. To do that, we let x equal 0, and this is going to take some math. Let x equal 0 and solve for y. So minus 1 squared plus 2. Now we just have to solve for y, and we get 4. I'm not going to do a lot of math on that. In fact, I'm just going to write that up there. And so the y-intercept is 0, 4. So now we go to the x-intercepts. And to find the x-intercepts, we just let y equal 0. So we have 0 is equal to 2 times x minus 1 squared plus 2. And sorry, my computer's trying to catch up here. Now we have to solve this equation with a square. So we're going to put the 2 on the other side. We're going to divide both sides by 2, and we get negative 1 is equal to x minus 1 squared. But at that point, we can stop. because you can't square something and get a negative number. That's impossible. So that tells us that there are no x-intercepts. No x-intercepts. So remember I told you that you know, this problem is not going to have any x-intercepts. Well, this is what tells you. Okay, so part 5 is going to we're going to find the directrix. And to do that, we're going to find P, which is 1 over 4a, and so we have to plug in a. And up here we see a is 2, so we're going to plug in 2 there. And we get 1 over 8. So now we're going to find the equation of the directrix, which is always equal to the y value of the vertex minus p. And the y value of the vertex is 2. And then we're going to subtract p, and p is positive 1/8. So the equation is 1 and 7/8. So now we're going to find the focus, and to find the focus, the x value of the focus is always the x value of the vertex, and the y value of the focus is always the y value of the vertex plus p. So the y value of the vertex is 1, and the y value of the vertex is 2, and we're going to add p, which is 1/8. So the focus is 1 and 2 1/8. So we don't really have time to, you know, color all this stuff. I might do that later. But let's see here. Now we're ready to graph. So the vertex is 1, 2. The line of symmetry, as usual, just goes right through that vertex. It's a vertical line. Then 0, 4 is the y value, or the y-intercept, and the x-intercepts there are known. And the directrix is 1 and 7/8. So that's going to be about here. Roughly. And the focus is 1 and 2 1/8. 1 and 2 1/8, which is about here. So we probably need to graph another point, but we can see another point is just going to be there, so that's going to be good enough. And this is 0, 4, and the equation of the directrix is y is equal to 1 and 7/8. And the equation of the line of symmetry is x is equal to 1. And the vertex is, was it 0, 2? That was 1, I'm sorry, 1, 2. My mind's playing tricks on me. 1, 2, and the focus is 1 and 2, or 1 and 2 1/8. So maybe I can go up here. 1 and 2 1/8. Okay, so that's pretty much it for that particular problem. If you got those answers, good job. Okay, so I want you to try number 6, and when you come back, we'll do it together. All right, we're back. So first step is to identify the form. This is intercept form, so we're going to label constants. A is 1 because there's nothing there. M is equal to 3. Remember, you always change the signs, and N is equal to 4. So the first step is to find the vertex. And to do that in intercept form, we use this formula. And we have 3 plus 4 over 2, which is equal to 7/2, which is 3.5. And I know what you're thinking. You're thinking, I don't want to deal with the decimal. Well, I don't want to deal with the decimal either, but sometimes you have to do that. So let's see here. Now we're going to plug that in to find the y value of the vertex. So we have 3.5 minus 3 times 3.5 minus 4. And that would be 0.5 times negative 0.5. And that's going to be negative 1/4. Multiply those together, it becomes negative 0.25, which is the same thing as negative 1/4. So the vertex is 3.5, or we can say 3 1/2, however you want to do it. 3 1/2 and negative 1/4. Step 2, to find the line of symmetry. And that's going to be x is equal to the x value of the vertex. Step 3 is to find the y-intercept. And to do that, of course, we let x equal 0. So y is equal to 0 minus 3 times 0 minus 4, which is equal to positive 12. So the y-intercept is 0, 12. Now we're going to find the x-intercepts. And this step, thankfully, is going to be really easy. We let y equal 0, but this is an intercept form, so we can just see the intercepts just by looking at it. It's going to be 3 and 4. 3, 0, and 4, 0. So usually that step is pretty involved, but not in this case. So now we're going to find the directrix, or the equation of the directrix, that is. And that is just, well, first of all, we have to find p in order to do that. So p is equal to 1 over 4a, and a is equal to 1. You can see up there it's equal to 1. So we have 1/4 for p. So now the equation of the directrix is y is equal to the y value of the vertex minus p. Y value of the vertex is negative 1/4. And then we're going to subtract p, which we just found is 1/4. If we do that, we get negative 2/4. I want to put a divider here so things don't get confusing. We get negative 2/4, which is the same thing as negative 1/2. So that's the equation of the directrix. And now finally we're going to find the focus. And the x value of the focus is the x value of the vertex, and the y value of the focus is the y value of the vertex minus p, or excuse me, plus p. So the x value of the vertex is 3 1/2. The y value of the vertex is negative 1/4, and then we're going to add p, and p is positive 1/4. So the coordinates of the focus are 3 1/2 and 0. So now we're ready to plot points. The vertex is 3 1/2 and negative 1/4. 3 1/2 and negative 1/4. That's going to be about there. All right. Line of symmetry is going straight through there, as usual. Straight through the vertex. Always a vertical line. And intercepts, or y-intercept is 0, 12. So as you can see, the y-intercept is going to be off the graph, but that's okay. We can just change the graph. So there you go. Now we have a better graph. So 0, 12 is going to be here. That's the y-intercept. And the x-intercepts are 3 and 4. So 1, 2, 3, and 4. As you can see, is going to be a more narrow parabola. Directrix is negative 1/2. So that's going to be about here. and I can go ahead and write the equation. Y equals -1/2. And focus is 3 1/2 and 0. 3 1/2 and 0, so it's going to be right on the x-axis. So that's about there. And the vertex, I think, is about there. So now we're going to connect the dots to get a feel for what this looks like. So looks like it's going to look something like that. And again, we could make a more accurate graph if we plotted more points, but that would be more work. Okay, now we have 0, 12 for the y-intercept, and the x-intercepts are 4, 0 and 3, 0. And the line of symmetry is x is equal to 3 1/2. Write that over here, 3 1/2. And the focus is 3 1/2 and 0. And the vertex is 3 1/2 and -1/4. Sorry, I'm just waiting for my computer to catch up here. And that's it. So we have the x-intercepts, the y-intercept, the vertex, the focus, and both lines and the equation of the line. So there you go. If you got that one right, good job. Okay, so I want you to try number 7. Number 7 is going to be a little bit more difficult because I think the x-intercepts are going to be irrational. I believe so. So why don't you go ahead and try number 7, and when you come back, we'll do it together. All right, we're back. So first step is to identify the form of the quadratic expression, and obviously it's standard form. So we're going to label constants. And first step, as usual, is to find the vertex. And to find the vertex, we use this old formula from our old familiar formula. B is negative this time, and A is also negative. And so we end up with -2. And to find the y value of the vertex, as usual, we just plug in the x value of the vertex into the original expression. And so we get the following. And that's -4 plus 8, and all that reduces to 6. So the vertex is -2, 6. And the second step is to find the line of symmetry. And that's really easy. It's just going to be x equals whatever the x value of the vertex is. Step 3, we're going to find the y-intercept, which in standard form is going to be really easy. In standard form, the y-intercept is always this number over here, so 2. So y-intercept is 0, 2. And now we're going to find the x-intercepts. And to do that, of course, we let y be 0. So we have 0 equals -x squared. minus 4x plus 2. And now we have to solve this quadratic equation. And remember, when you have standard form, there's 3 ways to do it, but we never use completing the square. We're either going to factor or try to use the quadratic formula. And I don't know if we can factor. It's going to be a little complicated to do that, so I'm just going to use the quadratic formula. And it's always good to write the formula that you're using before you actually utilize it. So we're going to plug in b, which is -4, wherever it says b, and -4 times a, which is -1, times c, which is 2, and then over 2 times -1. Okay, so now we just have to simplify that. I want to put a divider here. So we have x is equal to 4 plus or minus root 4 squared. Maybe I can just do that. 4 squared is 16. Minus 4 times -1. So all this stuff here, we have 2 times -1 is -2. And then -2 times -4 is +8. So we're going to add 8, and on the bottom we have -2. Let me just double check that. Everything looks right. Okay, so let's continue to simplify this. So 16 plus 8 is 24, and we're not allowed to have a perfect square factor inside a square root. So I'm going to change the form of that. That's going to become 2 root 6. Now, if you need review on how to change root 24 to 2 root 6, you can go to my classes on roots in this course. Remember, that's just review stuff. Now, we're going to take this polynomial and divide by this number here. And so 4 divided by -2 is -2. And 2 root 6 divided by 2 is just root 6. And when you divide a plus or minus by a negative, the plus or minus doesn't really change. So that means x can be -2 plus root 6, or x can be -2 minus root 6. And so the x-intercepts are the following. But that doesn't really do much for us, does it, when it comes to the graph? So we have to get out our calculator. And I'm going to type in 6 and then push the square root button. And then plus 2, and I'm going to change the 2 to a negative, and then equals 0.44. Or maybe we can just round off to 0.45. So 0.45. So that'll help us graph. So now we're going to do the same thing in the calculator. 6 and then the square root button, but now we're going to change that to a negative and then add it to 2 and then put a negative there, equals -4.45. So -4.45, 0. Okay, so now we have our x-intercepts and we have our estimated numbers to help us graph. Now we're going to find the directrix. But before we do that, we need to find p, which is 1 over 4a. And a, of course, we have up here, a is just -1. And I may go back and color all this stuff in later on just for your notes. And so we end up with negative 1/4 for p. Okay, so now that we have p, we know that the equation of the directrix is y equals the y value of the vertex minus p. And the y value of the vertex, I'm going to color purple. That goes there. And I'm going to make p green. And that goes there. So we have 6 minus negative 1/4. And that simplifies to 6 plus 1/4, so it would just be 6 and 1/4. So that's the equation of the directrix. Okay, so last step, we're going to find the focus. And the x value of the focus is the x value of the vertex, and the y value of the focus is the y value of the vertex plus p. So I don't really probably don't need to really color this right now, but you get the point. So the focus is, remember our x value of the vertex was negative 2, and the y value of the vertex was 6. And then we're going to subtract p, and p is negative 1/4. Actually, we're going to add p. So the focus is negative 2 and 5 3/4. Okay, so now we're ready to graph. So let's graph the most important points. Our negative 2, 6, that's the vertex. 1, 2, 1, 2, 3, 4, 5, 6. And the line of symmetry is x equals negative 2, of course, so we can go ahead and draw that. And the y-intercept is 0, 2. I'm going to draw that. X-intercepts are 0.45, 0. So that would be about here. And negative, whoops, that's the wrong side. 0.45, 0 would be here. And negative 4.45, 1, 2, 3, 4, that would be about here. And what else do we have here? Let's see. I'm just double checking those points. So the focus is negative 2, 5 3/4. 1, 2, 3, 4, 5 3/4. So that would be about here. And the directrix is 6 1/4. 1, 2, 3, 4, 5, 6 1/4. That would be about here. So y equals 6 1/4. And I'm going to go ahead and connect these dots. And so we have our y-intercept, and our vertex is negative 2, 6, and our focus is negative 2, 5 3/4. And we have our line of symmetry, which is x equals negative 2. And x-intercepts, negative 2 plus root 6, 0. And we don't have much room here, but it's going to be negative 2 minus root 6, 0. And I think that's about it. Yeah. So, if you got those answers, good job. Okay, so I want you to go ahead and try number 8, and when you come back, we'll do it together. Now, we don't have time to do number 8 together, so I'm just going to show you the answer. So, go ahead and pause the video and check your answer. If you got that graph and those numbers, good job. All right, that was the class today. So if you want to take screenshots of all the work that we did to help you with your homework or to study for tests, you can go ahead and do that now. Here's screenshot number 1 and screenshot number 2 and number 3 and number 4 and number 5 and number 6 and number 7 and number 8 and number 9 and number 10. But don't go before you get your homework. Let's take a look at the homework. So these are the homework problems. And here's the answers to the homework. And remember, if you don't do that homework completely and correctly and neatly and keep it in order in your binder, you're going to learn nothing in this entire course. And also, see the letters in red, show all work. If you don't show your work and you just copy the answers, then obviously that's not doing the homework. So get that homework done, and I'll look forward to seeing you in the next class.